So center of mass, if we take this ruler, which is uniform, notice this is what, 30, a little bit more than 30 centimeters. So if I put my finger under the 15, I should be able to balance this. But what happens if you attach different weights now? Notice I put a lighter weight, I don't know if you can see this on the screen. It's a little plastic container I put at the end of the ruler. And my eraser, I put it on this end, which is a little bit heavier. Now this ruler is 20 centimeters. If I put my finger on 10, it's not going to balance. It's heavier on this end. So I probably got to move it closer to this end to balance it, somewhere here, to compensate for the extra weight here. So the question, how do you find the center of mass without having to stick your finger there to see where it is? So we have an equation that will do that for us. Let me just get this stuff off this one. It says if you have a beam, and it could be more than one piece to it, doesn't really matter how many you have there, but if you have a beam like we did in that ruler there, and you put a mass here, a small mass, we'll call it M2, and we'll put a bigger mass here, we'll call it M1, and you want to find the center of mass, CM, center of mass. Where should you put your finger? That's your center of mass. Where should I put it there to balance that beam? In our book says, the equation, we can derive it, but they don't even derive it. They said the easiest thing to do, the center of mass is always going to be located the way you find it. It's you take the mass of the first one, how far from that, M1 times X1 plus M2 times X2 divided by the sum of the two masses. What's X1? So if this is you marking from here, this is the 0 mark. And this is this first value. This is your second one. X1 is that distance. That's X1. From here to there. What's that distance? What's X2? X2 is that distance from here to that point. Doesn't matter which end you start from. You could make the 0 right here. This will be X1 and that'll be X2. But you measure from one end of that. You go, okay, it's the mass of this times that distance plus the mass of this times this distance should equal. And it's really hard to explain that till we get to torque. Conservation of torque, Because you'll see when we start doing that, that's force times distance, and the force is mass times gravity. So if you put mass times gravity in them, well, guess what? The G's will cancel each other out. You end up with that equation. But as long as we know that's the equation we're going to be using, when we get to torque chapter, we'll explain that. So let's take an example here. We'll put some numbers on this one. So let's assume I attach a weight here or a mass on this end. I don't know, how big the mass here? We'll say 0.3 kilogram. And the second mass is 0.2 kilogram. And we know this beam is 0.8 meters long. I want to find where the center of gravity is. Now, let me ask you, would it be at 0.4? No. Would it be on this side of the 0.4 or on that side of the 0.4? On the left side toward the 0.3 or on the right side toward the 0.1? The center of gravity will be here. So let's say the center of gravity is going to be here. Do you want to measure the distance from here or you want to measure it from here? You choose. Doesn't make a difference. You want to measure it from this or you want to measure it from this end? You want this end? Okay, this is the 0. Then that distance from here to there, I'm going to call that x. So the center of mass, it's going to be mass 1, which is 0.3, times the distance from here to there, which is what? X, plus mass 2, which is 0.2, times the distance from here to there, which is what? 0.8. All divided by the sum of the masses. What's 0.3 plus 0.2? 0.5. Do you agree with that? Not me. I don't agree with it. Why? How far this weight from this mass from this point? When you measure the distance, it says take mass 1 times the distance from the point you're measuring. I'm measuring the distance from that point. So that distance really should have been a 0 here. If I decide to use that distance as 0, that mark as 0, yeah, this one will be 0.3 times x, will be a negative x actually. And that will be what? Matter of fact, I'll do the problem that way too after that. But if you're trying to use this as 0, your 0.3 kilogram is right as 0. So let's see what the center of mass should be then. That's 1.2 times 0.8, which is what? Is that 0.16 over 0.5, which is 0.32 meters from this end. Now what happens if I decide to use the center of mass as 0? I said, no, I don't want to do it that way. That's my 0 mark. This is the 0.3 kilogram. This is the distance x. What's this distance? What's the distance from here to there? It's 0.8 minus x. If I use this as my value there. What's x center of mass equal to?
Why would you want to do that?
I can pick any point for reference. I can pick any point on that beam.
Would it still be 0?
No, because I'm using this as reference.
Is it always going to be the same answer?
Yep, that won't change. The answer will not change. So if I pick that point, so let's see. This one 0.3, and how far the 0.3 from here? What's that distance? X plus 0.2 times the distance from here to there, which is what? 0.8 minus x divided by the sum of them. What's the sum of them? 0.5. Now the difference here, if I'm making this my center of mass, so what's x my center of mass then is going to be the value? 0 in this example, right? Because I'm using that as the origin. I got to put a 0 there. Because I'm making that as my 0 spot. My center of mass is 0. Can I find what x is? That tells me how far should it be from this end or that end. So 0.3 times x plus, what's 0.2 times 0.8? 0.16. What's 0.2 times negative 0.x? Negative 0.2x equals 0. There's only one little mistake there. Did anyone spot the mistake? Where is that in relation to that point? Is it to the left or to the right? To the left, so that should be plus or minus. So that distance should be a negative. If you put a negative, what will happen to that? Negative. So what's negative 0.3, negative 0.5, negative 0.2? Negative 0.5x plus 0.16. 0.5x equals what? 0.16, x equals 0.32. That distance is 0.32 from this point. Is that the same answer? I could have picked any point for the center of mass. I mean for that, the calculation, to make that the 0 mark.
Did you divide by 0.5 from it?
To get that answer, that's what I did.
Oh,
I divided by 0.5 just in my head.
okay.
0.16 divided by 0.5, which is 0.32.
No, I mean like the original 0.5.
Yeah, there's over 0.5. What about
Oh yeah,
that one?
well, because when you to get rid of the fraction, you multiply both sides by 0.5, right, to get rid of the fraction? And sometimes I skip the math. I go, oh, just multiply. So what happens when you multiply? These guys will cancel each other out, right? And what's 0 times 0.5?
0.
Still 0. I could have picked that point as the 0 mark. I'll do it again. I don't want to spend too much time on the center of mass, but just trying to show you it really doesn't matter what we use there. If I pick this as my 0 mark, this is where the center of mass we said is going to be here. I call this, which one? You want to call this one x? Now, if I call this one x, it's not going to be 0.32. It's going to be what? 0.48. Why 0.48? Because the whole beam is what? 0.8. So if this is we did before, we did it twice, we got 0.32 on this end. What's 0.32 plus 0.48?
What if we didn't do it? We didn't know the answer.
Well, I'm just saying. I don't know the answer yet, but I'm just telling you, when I get my answer, I don't want you to say, oh, you got it wrong because you got 0.48. Because I decided to call this time this side x, not that side x. I can still call this side x. I'll stick with it. This video is a mess. I'm screwing all over. I might not post it. I don't like sloppy stuff. If you want to stick with this being x, okay. Because sometimes I change the label. I call that one x. So I'll start with this one.
Can you do a new paper?
No paper.
It's gonna run out. I said a new paper.
Oh, new paper. Was almost done with this. X center of mass is equal to, let's take this one, 0.2. How far 0.2 from that mark? 0. Plus the 0.3 here,
Negative 0.3.
negative 0.8, divided by what? 0.5. Negative 0.16 over 0.5, which is what? Negative 0.32. Why is it negative? It's to the left. Doesn't matter how you do it. You can pick any point for center of mass. What happens if you get 3 of them?